Good morning, students. Today we learn class 9th physics. The name of the lesson is Forces and Laws of Motion. This is an interesting topic which we learn today. In this topic, we learned about Newton's law of motion. Newton is a great scientist. It gives us three laws of motion: first law of motion, second law of motion, and third law of motion. So we start with our topic, Newton law of motion. We have take the first law of motion. Newton's first law of motion. A body at rest will remain at rest. Okay? And a body is in motion will continue in motion. Here is the two part. The first part, a body at rest will remain at rest. This is the first one. And a body is in motion will continue in motion. This is the second part. In a straight line with a uniform speed, unless it is compelled by an external force, here external force, to change its state of rest or of uniform motion. So we have to understand both parts separately. The first part of rest and second part of motion. Suppose a box is lying on a table. Suppose a heavy box lying on the earth's surface. The box will not move by itself. That is, it cannot change its position at the position of rest by itself. Here is a position of rest. It can change its state of rest only when compelled by the force of your hand. When you put your hand here, or you lift it. Thus the position of the rest of the box has been changed by the external force. The force compelled by your hands is a force external. By this observation, we can understand the first part. A body at rest will remain at rest. The tendency of a body to remain at rest, this tendency, the rest position tendency or stationary tendency, or if moving, okay, when a car is moving or somebody is moving, to continue moving in a straight line is called inertia. Here the new word introduced, that word is known as inertia. Then we have to understand what is inertia. Inertia is that property of a body or object due to which it resists a change in its state of rest or of uniform motion. Inertia is that property of a body or object due to which it resists, okay, it opposes. This body is in the position of rest. It opposes the change in position or is in the position of motion. A change in its state of rest or uniform motion. A body has more inertia, okay, then the force applied is in that body is more. Greater the inertia of a body, greater will be the force required. Suppose greater inertia, the force required to bring a change will also be greater. Greater force, okay. How can we say that it has more inertia. A body has more mass. Okay? Mass, more mass. If a body has more mass, it has more inertia. A body has lighter mass or less mass, it has less inertia. We can understand this by example. Suppose you are lifting a pan or you are lifting a heavy bucket. In that case, the force required to bring a pan is less in comparison to force applied to taking or lifting or bringing a change on that bucket. Then we can understand the next part of Newton's first law of motion. The second part says a body is in motion, will continue in motion. The second part of first law of motion, a body is in motion, will continue in motion. When we see the first part of Newton's first law of motion, we think that it appears the second part will be wrong. Okay? At first sight, it would appear to be wrong that a body moving at uniform speed in a straight line will continue to move. Suppose we can take example of bicycle. Suppose a bicycle is moving Suppose this is a bicycle. It is moving. Okay. If we stop paddling a bicycle which is moving with a uniform speed, the bicycle does not go to move forever. It will come to rest after some time. The moving bicycle has been compelled to change its state of uniform motion by the external force of air resistance and the friction of this ground. Or earth. Here the resistance of the air. If there were no resistance of air, no friction to oppose the motion of the bicycle, then according to the first law of motion, a bicycle keep on going ever and ever. Okay? Then we take some examples. When you take a carpet, we beat or you beat by a stick, the dust particle start coming out of it. Why it will happen? This is because the force of a stick. Suppose this is a carpet. And you beat it by a stick. This stick. Okay? The force of a stick makes the carpet move in to and fro slightly. Here the carpet moves like this and like this. But the dust particle tend to remain at the position of the rest or stationary due to their inertia. The dust particles are separated from the carpet and the carpet became clean. And then we take the second example. When a tree is shaken, its fruit and the leaves fall down. This is due to the fact when the tree is shaken, it moves to and fro position, but its fruit and leaves remain at the position of rest or stationary due to their inertia. Hence, they detached from the branches of the tree and fall down. There are so many examples in our surrounding. Okay? If this video is helpful to you, in that case, make a comment on the comment box. If you like this video, like it, subscribe it and share it. Thank you.